All right, this lesson is on applications of systems of equations, meaning that we'll be solving some word problems using two variables, or possibly more. Here is our first example. The width of a basketball court is 44 feet less than the length. The perimeter is 288 feet. Find the length and width of the court. Okay, so the first thing we want to do when we when we attempt to solve a word problem here is to define our variables. So we're going to let's use L for the length. So we're going to let L equal the length, and of course W will be the width. So those are my two variables that I'm going to be solving for. Now we need to come up with our equations. Now in the first sentence here it says the width, so let me write down W here, the width is, that's an equal sign, 44 feet less, so minus 44, than the length. So we know that W is equal to L minus 44. That is one equation that we have to work with. In the next sentence we have the perimeter is 288 feet. Now, since we're dealing with a rectangle, we know that the perimeter of a rectangle is the distance all the way around, which is 2 lengths plus 2 widths. And since the perimeter is 288, they tell us, we have the equation 288 equals 2L plus 2W. And there's my second equation. Okay, so here is my system of equations, right here. These two equations comprise my system, and I need to solve that system. I have a few options, but I think the one that I will take is I'll solve using substitution. And the reason I would pick substitution is simply because this equation here is already solved for the variable W, so it makes it rather easy. So what I'm going to do is I'm going to replace this W right here with what it's equal to, L minus 44. If I do that, I have 288 equals 2L plus 2W, but remember I am replacing this W with what it's equal to up here, L minus 44. I can now solve this equation for L. So I'm going to now distribute the 2, so I have 288 equals 2L plus 2L again minus 2 times 44 is 88, so minus 88. Combine your like terms. I've got 2L plus 2L is 4L, so 288 equals 4L minus an 88. Oops, let me change that. Okay. Add 88 to both sides. Let's see what we have here. 288 plus an 88 is 376. Add 88 to both sides. 376 equals 4L. And then if we divide by 4, we get our length. 376 divided by 4, according to my calculator here, is 94. Okay, so I've got L. Now, of course, I also need the width, so the easiest way to get the width is to back up all the way back to this first equation we came up with here. We know the width is L minus 44. So the width is going to be L minus 44, which is 94 minus 44. That gives me a 50 for the width. And of course we would, if I had room on the screen here, I'd check my result. But what we have here is that the length is 94 feet and the width of our basketball court is 50 feet. And we've solved our problem using two variables, our system of equations. All right, let's look at a second problem. For a particular concert, 3 cheap seats and 2 expensive seats cost $159.50, while 2 cheap seats and 1 expensive seat costs $89.66. What is the price of each seat? So once again, we're going to start by defining our variables. And up here, we're going to let's let x equal the price of a cheap seat, and y will be the price of an expensive seat. Now I need to come up with at least 2 equations to solve the system. In the first sentence, we have that 3 cheap seats and 2 expensive seats cost a total of $159.50. Now, 3 cheap seats would cost, since I got 3 of them, 3 times x, because the x is the price of 1 cheap seat, so 3 of them would cost 3 times x, whatever that amount is. Plus, we've got 2 expensive seats, and so that would cost a total of $2y dollars. And you put that all together, and that's the total cost, $159.50. That's our first equation. The second equation, we get basically the same way. 2 cheap seats and 1 expensive seat. 2 cheap seats would cost 2x dollars, and 1 expensive seat would just be 1y. And that adds up to, according to the problem, $89.66. So this is basically my system, and if I solve that for my x and y, I've solved the problem. Now, I am going to solve this system. Probably the easiest way to solve this system would be to use the addition method or elimination method, depending on our book. And I think I'm going to get the y's to cancel. And in order to do that, I'm going to multiply this bottom equation on both sides by a -2. Both sides. Rewriting the problem, or the equations, I have 3x plus 2y equals 159.50. The bottom equation now will become -4x minus 2y, and then we have 89.66 times a -2. Let me see what my calculator gives me on that. 179.32. Oh, and that's negative sign right there. Don't forget the negative sign. I can add these equations together, and I will end up with a -1x. Notice that the y's have been eliminated. And that will equal, let's see what that is, 159.50 minus 179.32 is a $19.82. And if I divide by -1, I have my result, x equals 19.82. Okay, so I've got my x. Now, of course, with the elimination method, I have to plug in to find the other variable. So I think what I'll do is I'll use this original equation here to do that. I could use the top one, it doesn't matter. Let's rewrite that. I got 2x plus 1y equals 89.66. And so I'm going to plug in that value for x there to solve for y. So now I got 2 times 19.82 plus y equals 89.66. And let's see what we get here. 2 times that is 39.64. Subtract from 89.66. And we get a result of $50.02. And we have solved our problem. We have a cheap seat will cost $19.82, and our expensive seat will cost $50.02. Problem solved. Okay, next example. How many liters of 30% alcohol solution and 80% alcohol solution should be mixed to get 100 liters of a 50% alcohol solution? Now, you may recall from a previous chapter that what we have here is a mixture problem. And we did solve these with one variable, but actually with two variables, they turn out to be, I believe, a little bit easier to solve. So I'm going to make the same sort of chart that I would in my previous chapter. 9 boxes. And on the left side here, we write down what we are combining to get together. I've got a 30% alcohol solution with an 80%. And then down here, we always put the mixture, which we want to be 50%. Across the top, percentage, in this case, percentage of alcohol. This is number of liters in this problem. And this is the amount, in this case, the amount of alcohol. Percentage is a decimal. 0.3, 80% is 0.8 or 0.80, and the mixture is 0.50. Now, number of liters of 30%, we don't know what that is. That's what we're looking for, so I'm going to make that the variable x. Number of liters of 80%, that's the other thing that I'm looking for, and so I'm going to make that my other variable y. Number of liters of the mixture, I want to end up with 100 liters. And so I put my 100 there. Now, if you recall the way we solved the mixture problems previously, we multiplied across to get the last column. So this is going to be 0.3x. This one is 0.8y. And this one would be 0.5 times 100 is 50. Now, we have two equations here. X plus y should add up to 100 because this x is our number of liters of the 30% mixed with y liters of 80%. We should get 100 liters total. So x plus y equals 100. And the other equation comes from the last column. 0.3x plus 0.8y equals 50. And that, right there, is our system which we want to solve. What I will do first is, let's eliminate the decimal in the second equation. And in order to do that, I'm going to multiply both sides by 10. Writing it up here now, that would give me 3x plus 8y, and I guess this side would be 500. I'll solve using the elimination method. I will multiply the top equation by -3. That'll eliminate the x's for me. Let's rewrite each one now. -3x minus 3y equals -300. That's what this equation becomes. And then this equation is the same. I haven't changed that any. Adding those two equations together, the x's cancel away, and I am left with a 5y equals 200. And if I divide by 5, I get 40. Okay, so I got y is 40. So if I go back to the chart over here, this one is a 40 right here. And since the x and the y are supposed to add up to 100, that means the x must be a 60. 60 plus 40 is 100. And so I've solved my problem. That means I need, let's see if we can fit it at the bottom here. I need x, which is 60 liters of the 30%, and I need 40 liters of the 80%. And that will give me the mixture that I need. All right, next example. Mark invests $40,000, some in an account earning 4%, the rest in stocks earning 6%. The combined interest is $2,040. How much did he invest at each rate? This is another type of mixture problem that we probably solved in a previous chapter, but now I'm going to solve it for you with two variables. So I'm going to do the same sort of chart that I did before. 9 boxes. And on the side here I have an account and I've got stocks. And then down here we have a mixture or a total. Total here is probably more appropriate. Across the top we've got our percentage, which is actually our interest rate. Number, not number of liters here, we got number of dollars invested. And then here we have the amount, and this would be the amount of interest in dollars. Now we're going to fill in the chart. Our account earns 4%. So as a decimal, that would be a 0.04, 4%. Our stocks earn 6%, 0.06. And percentage of the mixture total, this box does not apply to this problem, so we don't need it. We're going to cross that out. How much did he invest at each rate? So number of dollars invested in the account is our X. We're looking for that. Number of dollars invested in stocks, that is our other variable Y. The two things which we are looking for. Number of dollars total invested. It says that Mark invested $40,000. So the grand total here should be $40,000. Amount of interest, going way down at the bottom here, the amount of interest total is 2,040. That's where that number goes. Just like with all our mixture problems, we multiply across. 0.04x is the amount of interest earned in the account, and 0.06y would be the amount of interest earned in the stocks. And if you add those up, it should turn out to be 2,040. So that's one equation right there. The other equation is in the middle column. The amount of money X invested in the account plus the amount of money Y should add up to 40,000 total. So X plus Y equals 40,000. This is the system which we need to solve. Once again, just like the last example, I'm going to eliminate the decimals first. So I'm going to multiply this equation, both sides by 100 in order to do that. And I'll rewrite them up here. That gives me X plus Y equals 40,000. And the bottom equation becomes 4X plus 6Y equals 204,000. I will eliminate the x's by multiplying the top equation by -4. So both sides multiplied by -4. And to save a little room, I'm going to just rewrite it right here. So that would be -4x minus 4y. And then I got 40,000 times a4, which should be negative 160,000. Okay, so if I add these two equations together, these two right here, x's are gone. I've got 2y, and let's see what we have if we subtract 204,000 minus 160,000 is 44,000. Divide by 2, $22,000. Now, since y is 22,000, which would go here, we know that the total invested is 40,000, so that must leave 18,000 for x, because the 18,000 and the 22,000 will add up to the 40,000. So x must be $18,000. And our problem is solved. Let's see if we can write it down here in the corner. If x is 18,000, so we got $18,000 in the account. And we have $22,000 invested in these stocks. And our investment problem is solved. Let's see what we have next. A cashier receives 25 coins consisting of only nickels and quarters. The total value is $5.65. How many of each type of coin did the cashier receive? Another type of problem that can be solved is the mixture problem. We solved this one in a previous chapter, just like the other ones. Then we only use one variable. Here we're going to use two. It makes it a bit easier. So just like the last two examples, I'm going to draw my chart. Now here we've got nickels and quarters. So N for nickels, Q for quarters, and then down here we got our mixture or our total. Across the top, we do not have percentage here, and what we have instead is the price per coin, the dollar amount of each coin. Number of coins, and then this would be the amount, and this would be in dollars, the amount in dollars. Nickels are 5 cents, so that is $0.05 per coin. Quarters are $0.25, and then this box is not needed here. Number of coins, nickels, number of nickels in other words, that's what we're looking for. That'll be our X. Number of coins, quarters, that's the other item we're looking for. We'll make that Y. And then number of coins total, we know that in the problem we have a total of 25 coins. That number goes there. Multiply across. We have 0.05x in nickels. That's the total amount of nickels we have. And we have 0.25y dollars in quarters. If we add those together, we should have the amount total, which they tell us is 5.65. That 5.65 goes right there. So just like the last two mixture problems, our first equation comes from this column. X plus y should add up to 25. And this column, 0.05x plus 0.25y should add up to 5.65. That's our system which we need to solve. X plus y equals 25. Let's get the decimals, get rid of the decimals in the second equation. So I'm going to multiply both sides by 100 here. That will give me 5x plus 25y equals 565. Let's eliminate x by multiplying the top equation on both sides by a -5. And I'll just rewrite it under there to save a little space. It becomes -5x minus 5y, and that is negative 125. If I add those equations together, the x's do cancel away, and I'm left with a 20y equals 440. And 440 divided by 20 is 22. So there's our y. Since we are supposed to have 25 coins total, then that means x must be 3. It's 22 plus 3 is 25. So our answer must be, we must have 3 nickels and 22 quarters. And it wouldn't be too difficult to check that those nickels and quarters would add up to $5.65. Okay, I believe we have one more problem here for an example. Okay. This is an example of a rate time distance problem. We did solve some of these in a previous chapter. This one, however, is going to require 2 variables. With the rate, time, distance problems, if you recall, we needed 6 boxes. Across the top we put rate, time, and distance. And of course the key formula here is rate times time does equal distance, keeping that in mind. Luke Skywalker flies to the Rebel base 4,800 miles away. With a headwind, the trip takes 3 hours. The return trip will have a tailwind and takes 2 hours. Find the speed Luke is flying and the wind speed. Okay, so I'm going to have to let's write it over here on the side. We're going to let's let x be Luke's speed, and y will be the wind speed. So we have two things going on here. We've got the trip out and then the return trip. Let's do this. This would be better. The trip out is with the headwind. So let's write HW for headwind. And then the return trip has a tailwind, the tailwind trip. We know that the headwind the trip takes 3 hours, so I can put that number in there for time for the headwind trip. And the return trip took 2 hours, so that's a 2 there. Now the trip is 4,800 miles, so this is a 48, oh wait a second. Cancel that, let's back up. Let's do this first. The rate. Oops. The rate here. In a headwind, you are being slowed down by the wind. So if you're going X miles per hour, the wind will slow you down, and so you must subtract the wind speed. You're actually going to go X minus Y. This is your speed minus the speed of the wind, because you are going slower. The tailwind, the wind is at your back, it's pushing you, you're actually going to go faster, and so you'll be going X plus Y. Now, we know from here that rate times time equals distance, and so this is going to be rate times time, distance would be 3 times X minus Y. And the same thing here, this would be 2 times X plus Y. Now, for each trip, we know that the distance is 4,800 miles. If you go 4,800 miles out, the return trip would also be the same. So I know this distance must add up to 4,800, and this distance is also 4,800. And those give me the two equations which I need to solve. Let's write them down here. 3 times X minus Y equals 4,800. 2 times X plus Y equals 4,800. That's the system I need to solve. Now what I can do is I could actually get rid of this 3 here by dividing both sides by 3 like that. And that would give me X minus Y equals, that would be 1,600. And I could do something similar with this equation. I'll divide both sides by 2. And that gives me X plus Y equals 2,400. Now I can solve that system by adding the two equations together. If I add them together, the y's cancel away immediately, and I'm left with a 2x equals 4,000. Divide by 2. Excuse me. And I get 2,000. So I've solved for x. I've got Luke's speed is 2,000 miles per hour. I also need y. And in order to get that, let's use this equation right here. X plus y is supposed to add up to 2,400. So if we put a 2,000 in for the x, then that will give me y equals 400 for the wind speed. And I'm out of room here, so let me just write it up here. Luke's speed, 2,000 would be 2,000 miles per hour, and the wind speed is 400 miles per hour. And those are our two solutions right there. Ran out of room. Okay, and that is our lesson on solving applications with systems of equations.